So in this video, we're going to take a look at the products and quotients of complex numbers in their trigonometric form. And you can see that I've started you off with just defining Z1 and Z2. Now, we'll go ahead and we'll start with the product. And we're going to take Z1 and we're going to multiply it by Z2. So I'll just drop in Z1, that's R1 cosine theta 1 plus I sine theta 1 times R2 cosine theta 2 plus I sine theta 2. And we're just multiplying. That's all we're going to do. So R1 times R2, I'll go ahead and put those over to the side. And now when it comes to multiplying this binomial and this binomial, back in high school or wherever you probably refer to it as foiling, and so first, outer, inner, last, we just need to make sure we account for all of those, but it doesn't have to be in that order. And so that's kind of what I'm going to focus on now is doing this, but in a more logical order. So I'll go ahead now, and I'm going to multiply to get started the cosine theta 1 by cosine theta 2. So we've got cosine theta 1, cosine theta 2. And then I'm actually going to go ahead and multiply now the last part. So this part here and this part here. Now notice when I do that, I'm going to get an I squared sine theta 1 sine theta 2. But I know the I squared is going to be a negative 1. So that's going to be a negative sine theta 1 sine theta 2. Okay? Now, the other two parts that I have, notice carefully that when I do the remaining two parts, for example, I'd have this guy times this guy. I'd also have then finally this times this. But notice when I go ahead and multiply both of those, so when I multiply these two, when I multiply these two, notice how there will be an I in both of those. So what I'm going to do is thinking ahead a step or two, I'm going to factor out the I and just focus on the sines and cosines. So when we do this now, after factoring out the I, we'll get sine theta 1 cosine theta 2 plus cosine theta 1 sine theta 2. Now, if you need to write out a few more steps to confirm that, by all means do so. But we multiplied this out in a very specific reason because now, if you'll notice, what we have here and what we have here is one of your identities. So our R1, R2, but then we have cosine of a sum. So cosine theta 1 plus theta 2 plus I, and then we have sine of a sum. Sine theta 1 plus theta 2. So our complex product, Z1, Z2, is going to be R1, R2 times cosine theta 1 plus theta 2 plus I sine theta 1 plus theta 2. All right, so now we're ready to take a look at the quotient, Z1 divided by Z2. And we'll pretty much do it the same way, or at least start it the same way. We have R1 cosine theta 1 plus I sine theta 1 divided by R2 cosine theta 2 plus I sine theta 2. And when we divide, again, we're just going to go ahead and keep the R1, R2 off to the side. And then I'm going to go ahead and multiply top and bottom by cosine theta 2 minus I sine theta 2. So top and bottom by the conjugate of the denominator. And so in doing this, you can see the denominator is actually going to be pretty nice because those are conjugates. The outer and the inner will go away every time. Now for the last part, we will have a negative I squared. So again, for this last part here, I times sine theta 2, negative I sine theta 2. When we multiply, we get a negative I squared, which would be a positive 1 sine squared. So in our denominator now, all we have left is a cosine squared theta 2 plus sine squared theta 2. And then in our numerator, we'll FOIL this very similar to how we did in the last part. And so if we do this the same way, what we're going to end up with is cosine theta 1, cosine theta 2, plus sine theta 1, sine theta 2. Now we're ready to factor out the I from the two remaining terms. Sine theta 1, cosine theta 2, minus cosine theta 1, sine theta 2. I'll go ahead and extend that out. And this whole cosine squared plus sine squared here, this is underneath the whole thing. All right, so looks like now R1 over R2, the denominator goes away. That's an identity for 1. This part is an identity as well, as is this part. And so if you look carefully, that's actually going to leave us with now cosine of a difference, theta 1 minus theta 2, plus I sine of a difference, theta 1 minus theta 2. So our product now, z1 divided by z2, can be found in its trigonometric form by that formula. All right, in the first example, we've got now root 5 cosine pi over 12 plus I sine pi over 12 squared. And this really is a product because it's squared, so it's the entire base multiplied by itself twice. So if you don't like seeing it like this, you can always ignore that and just rewrite it again as root 5 cosine pi over 12 plus I sine pi over 12. And since, again, it's a product, our z1 times z2 would equal r1 times r2 cosine theta 1 plus theta 2 plus I sine theta 1 plus theta 2. And in this example, our r1 is going to be equal the root 5, which is also equal to the r2, and our theta 1, which is going to be pi over 12, is also equal to our theta 2. So because it's the base multiplied by itself twice, the r1, the r2, the theta 1, the theta 2 are all the same. So now it's just a matter of plugging it all in. So z1 times z2 equals root 5 times root 5 cosine of pi over 12 plus pi over 12 plus I sine pi over 12 plus pi over 12, which would give us 5 times cosine of pi over 6 plus I sine of pi over 6. If you draw your triangle for pi over 6 like we've done many, many times, if that's pi over 6, we've got a 1, a 2, and a square root of 3. So cosine of pi over 6 would be root 3 over 2. Sine of pi over 6 would be the 1/2. And so to write this in a plus bi form, we would have 5 root 3 over 2 plus 5 over 2i. So there's the product of the original problem. All right, for the last example, we're given z1, z2, and we're looking for now the quotient. And so for the quotient, z1 divided by z2, our formula that we came up with is r1 over r2, cosine of a difference, plus I sine of a difference. So again, now it looks like we're definitely going to need r1, we'll need r2, we'll also need theta 1, and we'll also need theta 2 as well. So for r1, I'll go ahead and I'll square root negative root 3 squared plus 1 squared. So that gives us an r1 value of 2. For r2, we'll have 4 root 3 squared plus negative 4 squared, and gives us an r2 value of 8. Now, for tangent of theta 1, that's going to be a 1 over negative root 3. And for tangent of theta 2, that's going to give us a negative 4 over 4 root 3, which is a negative 1 over root 3. Now, for theta 1 and theta 2, these might very well be different angles, even though we're asking tangent equals, where tangent equals negative 1 over root 3. When I say they might be different because, remember, these are points in the complex plane, and we need to make sure that we're in the correct quadrants. So, for example here, tangent's negative in quadrants 2 and 4. So tangent's negative in quadrants 2 and 4. And our first point appears to be in quadrant 2. And I say that because we would need to move to the left negative root 3 and then up 1. But for our second point, notice how we would move in the positive real direction and in the negative imaginary direction. And so that would put us down here in quadrant 4. So again, we need to be a little bit careful to make sure we're in the right spot. So let's see, our tangent here would be a 1, a 2, a negative root 3, a negative 1, a 2, and a root 3. The reference angle would be a pi over 6, which means our theta sub 1 would equal a 5 pi over 6. And a similar discussion here would give us a theta sub 2 of 11 pi over 6. So now we've got all of our important information, R1, R2, theta 1, theta 2. So now it's just a matter of plugging it into the formula. So we would have Z1 over Z2 equals a 2, equals a 2 divided by 8 cosine 5 pi over 6 minus 11 pi over 6 plus I sine 5 pi over 6 minus 11 pi over 6. And when you simplify all of that down, it actually just ends up giving us a final answer of negative 1/4. I've kind of run out of room, but I'm hoping at this point you can handle a couple unit circle problems on the side of your paper. So it looks like, again, it simplifies entirely down for a final answer of negative 1/4.